Force equals mass acceleration, initial velocity. I need to test it! I need to change the impact time.
We got one of them.
Change in momentum.
Initial momentum, wouldn't that just be zero?
Potential. Our calculations tell us that it should take 0.77 seconds to fall. Let's go test it.
Test number 1. Watermelon from 2.91 meters.
Dang, he's really high.
Nice and good.
The potential energy, which is mass times acceleration times height, equals 45.63 joules.
The kinetic energy, which is 1/2 times the mass times velocity squared, was 45.63 joules. Due to the law of conservation of energy, potential energy is transferred to kinetic energy, so no energy is lost.
The final velocity, which is acceleration times time, is 7.55.
Because there is no initial velocity, there is no initial momentum.
Go.
The final momentum, which is mass times velocity, equals 12.08 kilograms meters per second.
The change in momentum, which is final momentum minus initial momentum, would be 12.08. In order to save this poor watermelon from breaking, we need to change the impact time for when it hits, because it hits with a lot of force. So to change the force, we need to change the impact time because it is directly proportional.
Test number 2. We have some bubble wrap to change the impact time.
God, Ben looks yoked climbing up this ladder. Oh man, look at those biceps. Looking pretty swole there, Ben. The watermelon survives with...
As you can see, because of the changed impact time, the watermelon has survived and we have saved it.
To show the relationship between impact time and momentum, we lowered the impact time by having one sheet of bubble wrap compared to multiple in test 2.
As you can see, the damage done in test 3 is a lot more than the damage done in test 2 because there is less impact time.
In conclusion, we found out that in our 3 tests, when you change the impact time, it lowers the force. As in test 1, when there is a very high impact time, the watermelon had the most amount of force, which resulted in the most amount of damage. Then we changed the impact time and made it greater, so the watermelon didn't even break when it hit the bubble wrap because it had to compress into the bubble wrap, changing the impact time greatly by 0.4 seconds. In test 3, we lowered it to show that with just a little bit of impact time, it also raises the force. So it had enough force to break the watermelon, resulting in it cracking and giving it damage. Gary approves, so we'll see what we can do with him next.
Test number 2. We have over here some bubble wrap to change the impact time.
Whatever. Throw it. Just don't like. Record it. As he goes to smash the watermelon with the back tire. Oh! There we go! That watermelon has been...
Yeah.
This is the semifinals in state. The discus throw. And he breaks the new state record! Almost! Come on, go yacht that watermelon. It's not even There we go! He destroyed that watermelon. And then he eats that. That was no competition for Ben Davis. The baby Ben goes ham on that watermelon. I'm kidding. Okay, fine here. I'll check it.